Hi, this is Sang Kim of 4D Motion. Before getting into the instructional portion of the video, first I'd like to just take you through the setup, placement of the sensors, calibration, and then a brief overview of each matrix mean, and then we'll go into the instructional portion. So to get started, first select the profile of the player you want to work with, and then make sure we're on the Modules tab. And in this case, I'm going to take you through the 4-sensor kinematic sequence setup, which is for the hip, chest, lead, upper arm, and the bat. But if you're just using the 1-sensor chest or the 2-sensor hip chest, it's the same process. You just don't have to do the arm and the bat. So first, let's click on the Start button next to the 4-sensor kinematic sequence. Okay, so I have 4 sensors turned on. They're paired to the device. They're charged. They're calibrated. So let's go ahead and hit connect. And again, if you have a 1-sensor chest module, you just have to have 1 sensor on. If you have the 2-sensor hip chest, it's just the 2. Now that they're all connected, you hit next. And at this point, we're going to put the sensors on. Now, each sensor will be specific to a location, so make sure you go through it step by step. So the first is a chest sensor, and one of my sensors has lit blue. So I know this is a sensor I want to put on. So I get my chest strap, and the chest sensor is important. It determines the orientation for the rest of the sensors. So I always want the white side of the chest sensor facing forward. So if you put it on the front, it should be white side out. If you put it on the back, which the chest harness is designed for, you want it blue side facing out or white side facing in. So as you can see, I have my chest harness here. I'm putting it in, and the blue side is facing out, the white side is facing in. Okay? So now when I put this on, the white side will be facing forward. If you happen to do this backwards, you'll know right away because everything will come out backwards, and then you could just do it over. Just make sure it's on snug, and want the sensor kind of right in the center of the back. Okay? So now we'll hit next, and we'll place the hip sensor. Now, you can either use a long strap as a belt, or you can use a clip and clip it on right on the hip. It's pretty much up to you, but if you are going to use the belt, make sure, or if it's their shorts or pants, make sure it's snug. If it's not snug and it's going to move around, then I would recommend using the belt. My belt's pretty snug. And I'm going to put the sensor on off to the side, not directly in front of me because I want the sensors to be able to relatively see each other, on my lead side. And the reason for that is just for connection issues. I'm going to be putting sensors on my lead side, so I want them together. If you're doing a trail arm configuration, I would put the hip sensor on my trail side. So this one lit blue. I'm going to put it on. And for all the rest of the sensors, it's always white side out. So you can see the white side's out. So let's hit next. Okay. The next one, the instructions say lead upper arm, or because I'm righty, lead left arm. So for this, I want it just above the elbow on the side of the bicep. And the reason for that is I don't want the sensor to be directly on top of the bicep because it'll get artificially tilted from the flexion of that muscle. So I take the sensor that's lit blue, and I'm going to slide it in here. Okay, then we're going to hit next. And the last one is the bat. So for the bat, there's a couple things you need to know. One is we want to place it on the handle kind of as low as possible that it's not interfering with the player. We don't want it too high up. We don't want it to get hit on a pitch. And we also don't want it on the angle part of the bat. And then the second thing is the triangle portion, the notched portion, should be facing towards the barrel. And when you put it in, the LED should be facing towards the barrel, white side out. So I stick it in one top corner, the other. Put in the point, make sure it's secure, and we're ready to go. So let's hit next. Okay, now it's time for the user pose calibration. I'm laying the bat down because we don't need to calibrate the bat. So when you're calibrating, there's a couple of important things. First, you want the person standing in the position that they would if they were hitting. So if I'm going to be hitting that way, catchers here, pitchers here, I want to calibrate like this, not like this, and not like this. So essentially on the line, okay? The second important thing is the posture. Per the diagram, we essentially want all the segments to be vertical. We don't want any tilts this way. We don't want any tilts this way. And we don't want any of the joints bent. And we want a neutral spine. So make sure the players have elbows are locked in, palms facing the sides. And we want this arm to be vertical with respect to the ground. So you just have to hold this position, press the next button. So the player just has to hold that position between the two beeps. I think the countdown is set at 3 seconds by default. You can set it to 1 because you're going to be there. The purpose of the countdown is if you're performing this by yourself and you need to hit the button, give yourself time to put yourself in the pose, you could set it for like 5 seconds or whatever. So now that we're fully calibrated, and by the way, you only have to calibrate once per session. You don't have to do it every time. The only need to recalibrate is if you're changing the target line or if the person moved the sensor and you feel like you need to recalibrate them. But essentially, at this point, we're ready to go. So let's go ahead and hit next. So at this point, there's really only a couple options here. One is the countdown time. Again, I'd set that to 1 if you're working with the player. If you're working by yourself, maybe you need to set to 5 seconds. And then the second is the recording time. Anywhere between 3 to 5 seconds is typically enough for the swing. So what you want to do is just have your player get ready, again, on the line. And when they hear that beep, you want to go ahead and swing. So just going to take a nice, easy swing. Go ahead. Okay, that's it. At this point, the sensors are going to download the data, capture it at a fairly high frequency. You just want to make sure you're a reasonable distance from the player so that the sensors can download the data. They don't walk off to the bathroom while this is happening. And now we have the data.
So let's take a look at the results screen from the 4-sensor kinematic sequence module. The first box is the transition sequence. So this is the sequence in which the hip, chest, arm, and bat are initiating their transition into the swing. You'll see in the upper right corner of the box what the ideals are. So it's really a ground up proximal to distal sequence that we're looking for, hip, chest, arm, bat. In this case, we got a good transition sequence. The next box is a deceleration sequence. So this is the order in which each segment reaches its peak and starts to decelerate. And we're looking for the same sequence, hip, chest, arm, bat, because again, the energy should flow from the ground up, and the hips need to decelerate in order to transfer energy efficiently to the chest, and then chest to the arm, and the arm to the bat. So in this case, we're out of sequence. The chest went first, arm, hip, and bat, in which case we'd want to work on getting the correct sequence. The next box is simply the peak rotational speeds of the chest. The next box represents the peak rotational speeds of each segment. And again, this will depend on the level of the player, but we want to see improvements and we want to see speed gains from segment to segment. Which leads us to the next box, which are the peak rotational speed gains. So typically we want to see 30 to 40% minimum from the pelvis to the chest and the chest to the arm, and then 100 plus improvement from the arm to the bat. And what you're often going to see is when a player fails to use his core segments properly, you're going to see a very high number from the arm to the bat. So most of the swing is coming from the arms and not leveraging a good flow of energy throughout the body. So in this case, the chest actually moves slower than the hips, The chest to arm was good, and then, as mentioned, the arm to the bat was abnormally high, but that's mostly a result of inefficient use of the rest of his body. The last segment is kinematic timing. So this is a time in milliseconds of separation between the hip to the bat, the chest to the bat, and the arm to the bat. This is another way of thinking about separation and sequence. So it's not just the amount or the order, but how much time from the peak of the hip to the peak of the bat, the peak of the chest to the peak of the bat, and the peak of the arm to the peak of the bat. Okay, and in general, from a pure energy efficiency process, we're looking for a longer amount of time between the peaks to generate as much power and speed as possible.
So when you select the show statistics, we allow you to set the date range on the top, and then you could start to see the trends. So the sequence stuff will give you percentages, what sequence for both transition, deceleration, do you do most of the time by percentages, and then on the bottom of the screen, we'll show you the running numbers for every one that you did. And then if you see one from the list that you want to particularly review, you can just click on that, and then it'll take you to that particular one. And if you want to go back to statistics, you just click Show Statistics on the bottom of the screen. Okay, well, hope that was useful. Stay tuned for the instructional part of the video. Thank you.
Hey guys, Rick Strickland with Train with RSB, Rick Strickland Baseball, and 4D Motion. Here with young Josh Griffin, middle infielder, senior in high school. We're going to go through the 4D, 4-sensor kinematic sequence module. Okay, so let's talk a little bit about the kinetic sequence. The kinetic sequence, basically, we're going to talk about 4 main contributors to the swing: the pelvis, hips, if you want to call it that way, the core, trunk, chest. Then we'll look at the lead arm, and we'll look at the bat will be the 4th piece of the component, which is we have it laid down here on the ground. The pelvis, let's talk about its role as far as the kinetic sequence. The kinetic's going to be the biggest conduit of ground force. So we have to be able to have good ground mechanics so that ground reaction force can actually come from the ground up to the ground. So the pelvis will turn itself into a conduit of that. So it has to be very stable. In order for the chest to turn that into rotational speeds, that also has to be stable. We've had a lot of kids who will be all over the place here and moving all around so that the rotational acceleration doesn't work as efficiently as we'd like it. And what you'll see with the athlete in a 4-sensor kinetic sequence, you'll always see a lot of times in a transition, you'll see that the arm will actually form as a conduit from the pelvis to the arm instead of the trunk. So the trunk's not being used hardly at all. There's some dysfunction going on there. So we're going to look at the metrics. There's 4 key components to the metrics that we look at. We're going to look at the transition, and the transition is as the first joint or first contribution to the swing, which one transitions and move forward. So what we'll see is these sensors will all be moving in a negative light, but we're measuring in the transition which one of these things actually move towards the target the first. And usually what we'll see is pelvis will transition first, then the trunk, then the arm, and then the bat. It's not always necessary to be successful, but usually the pelvis and the trunk for sure. Good ball strikers will get that. But usually what I'll see in these young guys is because they don't stabilize with the pelvis, don't stabilize with the trunk, you'll see this arm will actually jump in front of the chest. So we want to train that so that we can pass energy up the chain in the kinematic sequence as efficiently as we possibly can to be able to perform that swing. Well, the biggest thing we're trying to contribute is to create as much kinetic energy as we can so we can create as much power, much force out to the end of this bat as we possibly can do at this point. So one of the key things that we do is we try to create a little rhythm, kind of create a little timing. And so I'm not going to have Josh use the bat at this point, but we're actually going to use a towel. All right. So I'm going to grab a towel here. all right? And we'll use this towel. We're going to create a whipping action, all right? So basically, all I'm going to have Josh do is start with his back foot up in the air, and he's going to go here, slam on the ground, and then whip the towel. Good. And so what we want to do is this arm and this bat should perform as if it's a whip. All right. So we want to get the bodies to turn to pull. Why do I like to use something that's unstable like this? Is because when you put a hard instrument in a player's hand, what you're going to see is that they can actually apply a lot of force to that handle. Usually, pulling the guys who are over the top in the sequence will be arm first. You'll see the top hand actually will push down this way, but really this because you don't have the tension or the stiffness in the bat, it allows the chest to actually rotate and get out in front. So you're going to see a lot of times, especially if you test it, and you can do this with this. That's simply just take the bat sensor and strap and wrap it around here, and you can actually get this in the sequence. The last thing I didn't talk about is the metric is the pelvic timing. That's really a simple way to look at how many milliseconds before impact do these joints actually peak in their rotational speeds. And you want the pelvis to peak the furthest away from impact, and then the chest will peak, and then the arm will peak. The bat will be the last. And so what you're going to see when you start to test these things, both with your bat and your or any type of instrument that like a towel or a rope or something like that, you should see those timing sequences peak at that point. So we're going to have Josh go ahead and do the drill here, right? A couple times where he does the swing here. Good. Now you can load it. You can go ahead and create external rotation with that trail arm. What do you feel here, Josh?
It feels like it's all in sequence.
Feel like in sequence? Do you feel like there's a stretch going across your chest a little bit as you turn? Good. All right. Now another way we'll do this, and we'll do it with a rope. All right. So I made a little knot in this rope here. We'll have the hitter actually here, and basically what I'm going to have him do is at impact, I'm going to have him brace. Arm will come out. These will stop. All right. And if you want to, you can roll it over here so you don't swack yourself in the face. All right. Go ahead. Good. Stay in a side bending position, because if we don't, what happens to rotation? If we stand up, we don't rotate quite as much, and so you're going to end up using your hands to do that. So you don't want to stand up. You want to stay in this side bending rotation so acceleration stays high, and we'll go here. All right, go ahead. All right, go ahead and brace. Do you feel that tension? You feel in your lat, and do you feel it across your chest to decelerate? And then the last thing that moves forward and accelerating real fast is what? Arms, and then the rope, because the arms do slow down a little bit, not much. Hand doesn't slow down, especially before impact. There won't be we don't want a whole lot of deceleration going on with the arms before impact and the hands before impact. But the one instrument that should be moving the fastest when we strike the ball should be the tip of the bat or the sweet spot of the bat. And in this case, the rope. Go ahead. Good. Another way we train it, we can do not for now, but for a later date, we talk about how we actually train the lead arm and the trail arm. But we want to make sure for the sequence, we want to make sure that the chest is actually fused together and locked. So a lot of times when you see that the arm is actually out in front, you're not going to have a whole lot of pronation in this lead side. Because when that lead side happens here and this supination happens on the trail side, what you do is you're delaying the start of the bat in its transition towards the ball. Okay? Good. Do it again. Try to give me some supination, pronation. Better. Good. And you feel that all across your core, don't you? All right. So the core has to brace in order for the instrument to fling forward. Good. 3, 2, go. Chest popped up a little bit here. So if the chest pops up, we're going to see the arm actually get out in front of the chest. So we got to have the athlete stay stable. If the spine is not stable, the body will compensate. And usually, if you'll see in unstable spines, you'll see this extension flexion going on again. So again, we have the arm transitioning before the chest in that particular swing. All right. So try it again. Let's try the rope bat here. All right. And all I do with the rope bat is I just take the sensor off, and there's no recalibration that needs to happen here. He's not going to hit a ball. You don't need to do this as far as here. I'm just going to take this thing and just tape it to the rope. Okay. And we're going to try it here. No. Yeah. 3, 2, go. Good. And so what we're doing is we're training these two to be the dominant forces in the action, not the hand and the chest. Usually, when you do these drills, a player can actually feel a lot of the times the bigger muscles actually pulling the bat instead of the smaller muscles, the arm and the hands, which is represented by the bat sensor being the most dominant force in the swing. So, again, I'd like to take your time. Thank you for joining us today. Feel free to reach out to us with any questions you may have. Thank you.